Alkynes are unsaturated hydrocarbons having the general formula CnH2n-2. We have seen the formation of alkynes. Let's look at some of the reactions of alkynes. We know that alkynes give addition reactions. This is because alkynes are unsaturated hydrocarbons. All unsaturated hydrocarbons always tend to become saturated, and this is done by undergoing the addition reactions. Let's look at some of the reactions. So we have ethyne. When it is made to react with chlorine, it gives the addition reaction. In addition reaction, the triple bond breaks into a single bond. Now this happens in steps. That is, in the first step, the triple bond breaks into a double bond, and in the second step, the double bond breaks into a single bond. So let's see how this happens. In the first step, we have ethyne reacting with chlorine. So the triple bond breaks into a double bond, and each chlorine atom attaches itself to one carbon atom to give the addition product. In the second step, we have this product now. It is made to react further with chlorine. So now the double bond breaks into a single bond. We already have these two chlorine atoms. Now these two chlorine atoms further attach themselves to each carbon atom. So now we get the addition product. So the addition reactions, that is ethyne and all alkynes undergo addition reactions. So the unsaturated compound changes into a saturated compound. This happens in two steps. In the first step, the triple bond breaks into a double bond, and in the second step, the double bond breaks into a single bond. Let's look at another reaction. In this case, we have ethyne. It is made to react with a hydrogen molecule. Remember, in this case, we use a catalyst, nickel. This again happens in two steps. In the first step, the triple bond breaks into a double bond, and each hydrogen atom attaches itself to one carbon atom. Now, in the second step, we have a compound which has double bond. So now the double bond breaks into a single bond. So when we have hydrogen atom, the double bond breaks into a single bond, and each hydrogen atom attaches itself to one carbon atom. So this is C2H6, which is ethane. So C2H6 is ethane. So from ethyne, that is a triple bonded compound, in the first step we get ethene, which is a double bonded compound, and in the second step, from ethene we get ethane. So the addition reactions of alkynes, from the unsaturated hydrocarbon, we get the saturated products. Another very important reaction for all organic compounds is the combustion reaction. All organic compounds on combustion give carbon dioxide, water, and they release heat. So if we take ethyne or propyne, on burning in the presence of oxygen, they give the same products. That is carbon dioxide, water, and they release heat. So, do alkynes give addition reactions? Is it true or false? We know alkynes are unsaturated hydrocarbons, and all unsaturated hydrocarbons, they tend to become saturated, and this is done by undergoing addition reactions. So yes, alkynes give addition reactions, and this is true. Alkynes are unsaturated compounds. In order to become saturated, they give us addition reactions. Another very important reaction for alkynes, as we had seen previously for alkenes, alkenes on reaction with ozone, that is the ozonolysis reaction, they form ozonides. Similarly, if we have alkynes, in this case we have ethyne. When ethyne is made to react with ozone, it forms a hut kind of a structure. So see, we have the two carbon atoms. One oxygen atom of ozone attaches itself to each of the carbon atom, and the other two oxygen atoms attach to one carbon atom each. So if you look at the three oxygen atoms, they form a hut-like structure. So from ethine, on reaction with ozone, we get ethine or acetylene ozonide. Ethine is also known as acetylene. So the product of this can be known as ethine ozonide or acetylene ozonide. So the reaction of ozone with ethine is known as ozonolysis reaction, and this gives us the corresponding ozonide. In case of alkynes, we get a hut-like structure. Have you ever seen cutting and welding going on nearby? You must have observed this flame which is used for cutting and welding purposes. See how cutting and welding takes place? The flame which is used for this purpose is the oxy-acetylene flame. That is, it is made from oxygen gas and acetylene gas. So one very important use of the ethine or the acetylene gas is making the flame, that is the oxy-acetylene flame, which is used for cutting and welding purposes.